All right, so we are starting off on question 10. So a gas station has a cylindrical fueling tank that holds gasoline for its pumps, as modeled below. The tank holds a maximum of 20,000 gallons of gasoline and has a length of 34.5 feet. Okay, so this has a length of 34.5 feet. Now a metal pole, so I don't know if you guys can like tell, but the metal pole is used to measure how much gas is in the tank. To the nearest tenth of a foot, how long does the pole need to be in order to reach the bottom of the tank and still extend 1 foot outside the tank? Okay, so this is 1 foot. That little part needs to be 1 foot. Now, like, think of like turn your real world brain on for a second. When you like this pole sticks down in the tank so that this is like the diameter. So the pole is equal to the diameter of this entire tank. Now that is what we're trying to find. Okay, so we kind of need to work backwards from like finish and kind of work our way towards the start of the problem, like how we're used to doing it. All right. So here's the thing. We were given that the tank holds a maximum of 20,000 gallons of gasoline. And in 1 cubic foot, there are 7.48 gallons in 1 cubic foot. Okay. So to find the volume of this tank, we're going to take 20,000. We're going to divide it by 7.48. Okay. So 20,000 divided by 7.48 gives us 2673.796791. All right, so this is the volume of the tank. All right. So now let's plug this into our volume formula for a cylinder. So volume is equal to pi r squared times the height. Okay, so we were given the volume, so that's what our equation is going to be set equal to. 796,791 is equal to pi r squared. So the radius, we don't know the radius because that's kind of part of the diameter, if you will, right? Now the height, what we're trying to find, now the height is 34.5, okay? So now to find the diameter, we first got to solve for the radius. All right, so let's first divide by 34.5 pi by both sides. Okay. So we're going to take our volume, so 2673.796791, and then I'm going to put this in a fraction form because it's weird when you put this in the calculator, so be careful how you put it in the calculator. Pi. So r squared is equal to this. Okay, now to find the radius, we're going to take the square root of both sides. So the radius is equal to 4.966834796. Okay. Now the diameter is twice the radius, so we need to times the radius by 2 to get the diameter. So the diameter is 9.933669.592. Okay. Now here's the thing, we want to find the length of the entire pole. We just found the part that's in the tank, so we need to add 1 to it because we want the pole to stick out 1 feet. Okay, so we're going to add 1. So the pole, so plus 1, so the pole needs to be 10 point, what does it say at around 2? And here's 1/10 of a foot, so 10.9 feet. Now remember, I want you to write the, I want you to write the entire decimal, which I did not do that. I'm just gonna write it down here. Now I make you guys do this because if you say have a rounding error and you round that wrong, I mean, I don't know if you're gonna get some credit, but it might not be as much. And like if you just wrote like 10.8, right? And you didn't write that, then it's a little screwy. So just make sure you write that full decimal always. Okay. All right, so that is that question. Let's look at number 11. Okay. So a soup can is in the shape of a cylinder. So let's draw our cylinder. The can has a volume of 342 centimeters cubed and a diameter of 6 centimeters. We want to find the height of the can in terms of pi, and then we want to determine the maximum number of soup cans that can be stacked on their base between two shelves if the distance between the shelves is exactly 36 centimeters. All right, so let's look at the second part after we find the height. Okay, so let's that be our first job. So our height is what we have to find. Our diameter is 6 centimeters, so our radius is 3 centimeters. Our volume is this. Okay, so we're gonna kind of do like we did up here. We're gonna go work backwards. All right, so our volume formula for cylinder is pi r squared times the height. Okay, our volume is 342. I'm gonna set that equal to pi 3 is our radius squared times height. Height is what we're solving for. Now we have to be super, super careful. We want the height of the can in terms of pi. Okay, so I'm going to divide by 3 squared first, and then I'll divide by pi, just so we don't get confused. All right, so 3 squared is 9. So I'm just going to divide by 9 both sides. Now 342 divided by 9 is 38 pi times height. So now we want to solve for h. So to solve for h, we divide pi by both sides. So our height is equal to 38 divided by pi. Okay. Now let's go back and read that second part of the question. We want to determine the max number of soup cans that can be stacked on their base between two shelves. Okay, so imagine if you're at the store or in your kitchen or whatever, and you have two shelves, okay? Kind of picture that. Now, if the distance is 36 centimeters, how many can we fit? So we kind of want it to look like this. Okay, but we need to actually like figure that out. So what we're gonna do is we're gonna take 36 and we're gonna divide it by our height. So 38 divided by pi to find the maximum amount of cans. Okay, so I'm gonna use alpha y equals fraction. So 36 over 38 over pi. So we have 2.976245672. Now here's the thing. If we round up to 3, that would be too much. Okay, so this is one of those circumstances where you're gonna have to put on your thinking brain, common sense brain or whatever and kind of think about the real life situation. We can't fit 3 cans in there because this is almost 3, but not exactly 3, not at least 3. Okay, so we can fit at least two cans, so we have to round down. So we can fit 2 cans on the shelves. because three cans cannot fully fit. All right. So that's question 11. Let's look at number 12. So Sue believes that the two cylinders shown in the diagram below have equal volumes. Is Sue correct? Explain why. All right, so this is the idea of Cavalieri's principle. I have no idea how to spell this. Cavalieri's principle. Okay, or Cavalieri's principle states that if the base area the height and the cross section at any point along the height is the same, then the volumes are the same. Okay. So now let's look at each of these. So this has a height of 11.5 and a radius of 5. Now this also has a vertical height. Remember, the vertical from top to bottom is the height of the same thing. And now it has a diameter of 10, but obviously a diameter is twice the radius, so the radius would be 5. So they would have the same radius. Okay? So based on Cavalieri's principle, Sue is correct. Okay, so we have to explain why. So since the height and base area are equal, and they have the same cross section along the height, based on Cavalieri. Hold on, I'm gonna just give me 1 second. I'm gonna figure out how to actually spell this. Okay. Principle. They have the same volume. All right, let's go to the next page. All right, so the diagram below shows two figures. Figure A is a right triangular prism, and figure B is an oblique triangular prism. The base of figure A has a height of 5 and a length of 8, and the height of the prism A is 14. The base of figure B has a height of 8 and a length of 5, and the height of prism B is 14. Use Cavalieri's principle to explain why the volumes of these two triangular prisms are equal. All right. Now, here's the thing. They're both prisms, so to figure out the volume, remember you do the area of the base times the height. All right, now, it looks a little different, okay? These two, the bases, the triangles look a little different, but let's put it into our formulas. Let's put it in. Let's set up our formulas like we were gonna solve for the volume of each prism. Okay, so this is figure A. So the area of the base is 1/2 times base times height, because the base is a triangle. So 5 times 8 times the height, which is 14. Okay, so that's how we would find the volume of figure A. Now for figure B, volume of figure B, same thing. Area is, the base is a triangle, so area of the base is 1/2 times 8 times 5 times the height, which is 14. Okay. So now, looking at these formulas, are they the same? I think so. Alright, so let's explain ourselves. So let the volumes of the prisms are equal because of Cavalieri's oh my god, it's right here. Okay. Principle, which states that if the base area and height is the same, then they have the same volume. Since the base areas of figure A and B is the same, and the height is the same. Gosh. Is the same, then figure A and figure B have the same volume. All right, so let's do 14 and we're gonna do 15. That will be our last one for this video. All right, so let's look at 14. So a solid metal prism has a rectangular base with sides 4 inches and 6 inches and a height of 4 inches. A hole in the shape of a cylinder with a radius of 1 inch is drilled through the entire length of the rectangular prism. You want to find the approximate volume of the remaining solid in cubic inches. Okay, so we want to find the volume of this whole thing, okay, minus that hole in the middle. So the volume remaining is equal to the volume of the rectangle minus the volume of the hole. I'm just going to call it the hole. Okay. So now the volume of the rectangle, remember it's of a rectangular prism, it's the area of the base times the height. So the area of the base is 4 times 6, the height is 4. So we're doing 4 times 6 times 4. Now the volume, the hole is a cylinder. So cylinder, remember pi r squared times height. So pi, our radius is 1 and our height is 6. Remember, the height of the cylinder is this, 6, okay? So, times 6, all right? So let's put that in our calculators. So 4 times 6 times 4, 96, minus pi 1 squared times 6. So 18.84955592. So this minus this is equal to 77.1504448. Okay. Now in cubic inches, so we run around to the nearest whole number, which is 77, so choice 2. Okay. All right, let's look at 15. So in the diagram below, circle 1 has radius 4, while circle 2 has radius 6.5. Angle A intercepts an arc length pi, and angle B intercepts an arc length 13 pi over 8. So Dominic thinks that angles A and B have the same radian measure. Radian. State whether Dominic is correct or not. Okay, so radian, I boxed this word for a reason. When you see radian, remember theta is equal to S over R. All right, so let's find the radian measure for circle 1, and we're gonna find the radian measure for circle 2, and we're gonna compare them. Okay, so theta is equal to, remember this is arc length over radius. Okay, so my arc length in circle 1 is pi, and my radius is 4. Now, this cannot be simplified anymore. When you are asked to find the radian measure, do not simplify it into a decimal. Okay, leave it like this. Or simplify it as much as possible, but leave it as a fraction. Leave it as a fraction. Okay. Now let's take a look at circle 2. So we have pi is equal to, now the arc length is 13 pi over 8 over 6.5. Okay. Now we want to leave it in terms of pi, our answer. So I'm just going to put in 13 over 8 over 6.5, so 2.5, so as a fraction, that is just 1 over 4. So this is just pi over 4. Okay. So Dominic is correct. So let's actually go to the front of your page, front of your packet, where we've been writing down, where last video we wrote down some important things. I'm going to add that theta is equal to S over R. Formula, so theta is equal to S over R. So remember, we can only use this for radian measure only. Now S is equal to arc length, and R is equal to the radius. All right. So this is it for today's video. Make sure you come back for tomorrow, and I will have another video posted for you.